Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with 3.6, which is the rational function. So this is the second last subtopic for this chapter. So what is rational function? So when we have one polynomial divided with another polynomial, which is denoted as px divided by qx, where qx cannot be 0. So for example of rational function, we have negative 5 over x, 2x squared plus 1 over with 2x. We have x power of 4 plus 7x cubed divided by another polynomial function with the power of 3. And then x cubed minus 5x squared plus 3x minus 9 over with the x squared minus 3. So this is all the example of the rational function. And the rational function are divided into two, which is proper rational function and improper rational function. So the proper rational function when the degree of numerator is lesser than the degree of the denominator. For example, we have squared on the numerator, so 5x squared minus 2x divided by 3x cubed. And another example of proper rational function, we have here 3x power of 4 minus 2 divided by x power of 5. So for the second example here, the degree of your numerator is power of 4 and the degree of the denominator is power of 5. Now let's look at to the improper rational function. So improper rational function when the degree of the numerator is greater than or equal to the degree of the denominator. So for example, 8x power of 4 plus 5x divided by x squared plus 4x minus 9. So the degree of the numerator is power of 4 and the degree of the denominator is x squared. And then for the equal degree of numerator and denominator, we have 2x cubed minus 4x plus 2. And in the denominator also, our polynomial is in the degree of 3. So 3x cubed plus 7. So we have the, when we have in terms of improper rational function, we can convert the improper rational function to the proper rational function by using long division method that we have learned in 3.2, division of polynomial. So if you still remember, this is the form of division algorithm. We have px over dx is equivalent to the qx plus with the rx over dx. So let's proceed with the example here. Use long division to convert an improper rational function to proper rational function. So from here we have the degree of the numerator is x cubed over with the degree of the denominator is x squared. So meaning that the degree of the numerator is bigger than the degree of the denominator. Therefore, this is example of the improper rational function. So how can we convert this improper rational function to the proper rational function is by using long division. So let's apply the long division here. So x cubed plus 2x minus 6 divided by, so our divisor here is x squared minus 2. So what we have to put here in order to remove x cubed. So first, before that, so since we have a missing term here, so it's better for us to put 0x squared. So x cubed plus 0x squared plus 2x minus 6. And then divided by, the divisor is quadratic, x squared minus 2. So the first step, we need to remove x cubed. So, and we have x squared here. So we have to put x here and then x times with the x squared, so we will get x cubed, and x we have to times with the negative 2, so you will get negative 2x. So we can put here negative 2x. So for the x squared, we can just put 0 x squared, so it doesn't matter whether plus or minus. So what left here is this one will become 4x, and we have to bring negative 6 down, so we have this as a remainder. So why we have to stop here? Because the degree of the remainder is already less than the degree of the divisor. So this is our rx and this is our qx. So when we try to rewrite in terms of division algorithm, so that our quotient is x, so our px divided with the divisor, so it is equivalent to the quotient plus with the remainder divided by divisor. So when we put it x here, so our quotient just now is x plus with the remainder 4x minus 6 divided by the divisor is x squared minus 2. So why it is called as a proper rational function? So from this improper rational function, which is the degree of the numerator is bigger than the degree of the denominator, we can rewrite or decompose in form of x plus with the another proper rational function. So this one is already in terms of proper rational function, but we do have plus x at the back. So at the end in 3.7 we will learn what we have to do with the x. So at the end we need to combine with the terms that we get in quotient. So that's all for the 3.6. So we will continue in 3.7. Thank you.